Welcome, infrastructure admins. You are exactly where you need to be. Today, we're focusing squarely on your certification prep with this explainer titled exactly NCP-MCI 7.5-8.7 vDisk Selection, Live Migration, and QoS. We are going to thoroughly break down these core Nutanix storage functions, unpack the underlying mechanics, and give you the precise details you need to master your environment and totally ace this section of the exam. Okay, let's dive into this. Here is our structural roadmap for today. We'll start with why this topic matters, move into a vDisk selection walkthrough, and then do a live migration deep dive. After that, we'll get Storage QoS explained, jump into exam traps and edge cases, definitely pay attention to that one, and wrap up with key facts to memorize. Section 1. Why this topic actually matters. Look, mastering these storage functions isn't just about passing a certification test. It is literally the fundamental difference between running a resilient, high-performing cluster and dealing with a sluggish environment that's prone to unexpected outages. So before we get into the technical weeds, let's quickly ground ourselves in the baseline architecture. AOS, or the Acropolis operating system, is the core operating system of the Nutanix controller VM. It's the brain intelligently tiering data across your cluster. Then we have AHV, the Acropolis hypervisor, which is Nutanix's native enterprise virtualization solution built directly into AOS. Understanding how these two interact right at the storage layer is absolutely crucial. It's the key to unlocking everything else we're about to discuss. Section 2. Let's do a vDisk selection walkthrough. Now, what's really interesting about this architecture is how it dictates performance. When you spin up a VM, making the right disk configuration choice immediately sets the ceiling for its performance. You can see why SCSI is the default and absolutely preferred disk type for AHV-based VMs. AOS passes all disks to the VMs as raw SCSI block devices. This creates a really lightweight, highly optimized I/O path. The AHV host runs an iSCSI redirector, and when QEMU makes a login request, that redirector jumps in and establishes a highly resilient storage path directly to a healthy Stargate process, preferably the local one. The whole shebang basically bypasses unnecessary overhead, giving you maximum performance. So, while SCSI is your bold standard for performance, AHV does support a few other bus types for very specific use cases. For instance, you should use SATA or PCI-based disks when you're dealing with older Linux VMs, think RHEL 5, that just don't include the SCSI paravirtual drivers required by AHV. On the flip side, the IDE disk type should be strictly reserved for CD-ROM tasks. We're talking booting a VM or installing paravirtual drivers from an ISO. The IDE bus inherently has much lower performance, so it should never, ever be used for applications that actually require high storage throughput. Moving on to Section 3, our live migration deep dive. Okay, to really grasp live migration, we first have to understand the why. In Nutanix, storage attributes, things like replication factor, encryption, deduplication, and compression, are all applied at the storage container level, not the disk level. So imagine you have a live VM running on a replication factor 2, or RF2, container, and suddenly business requirements dictate it now needs RF3. Well, you can't just change the policy on the vDisk itself. Instead, you create a whole new container with the RF3 policy, and you live migrate the vDisk to that new container. And the best part? The guest VM stays perfectly active the entire time. No downtime. Let's see how this builds into a concrete workflow, specifically around disaster recovery. Because you actually cannot simply live migrate a vDisk if its VM is actively protected by a protection domain or policy. If you try it, it fails. So instead, you've got to follow this exact sequence. First, remove the VM from the protection domain. Second, migrate the vDisks to your target container. Third, add the VM back into the protection policy. And finally, configure your remote site with the details of the new container. It's a very specific dance, but it works perfectly when you follow the steps. Now here is a critical operational quirk you absolutely must anticipate. During a live vDisk migration, the logical usage of the vDisk will actually appear higher than its total capacity. Why on earth would that happen? Well, it's because the logical usage temporarily includes the space occupied in both the source container and the destination container simultaneously. Once the migration completes, the logical usage drops right back to normal. But if your target container doesn't have enough free space to handle this temporary duplication, the migration will stall out entirely. Section 4. Storage QoS explained. So to wrangle those noisy neighbor VMs, Storage QoS gives you granular control to limit the IOPS, that's input-output operations per second, that the storage layer will serve for an individual virtual machine. Setting these throttle limits is a lifesaver. It prevents runaway VMs from hoarding all your system resources. But you need to take note of two major administrative requirements here. First, utilizing Storage QoS requires an AOS Pro license or above. And second, you are strictly not allowed to configure or set Storage QoS while an AOS upgrade is in progress. Just keep those two rules in your back pocket. When you're in the Prism Central interface, you can throttle based on IOPS or throughput, and they are mathematically linked by the application's block size. To put that into perspective, let's look at the math. If your VM uses an 8 KB block size and you throttle it to 800 IOPS, your resulting maximum throughput is exactly 6.25 megabytes per second. Understanding this relationship is crucial for actually delivering consistent performance rather than just blindly typing arbitrary limits into the system. All right, Section 5, Exam Traps and Edge Cases. I'm putting my red team hat on here to simulate the pressure of the certification test. We are going to look at the exact, tricky limitations they'll use to try and trip you up. Let's start with a scenario. You were configuring a VM. You decide to attach an IDE disk for a quick boot task, but this VM also has UEFI Secure Boot enabled. So, what happens? Take a second to answer it in your head. Did you get it? The answer is, it fails completely. Specifically for AHV version 5.16 and later, you absolutely cannot use an IDE device if Secure Boot is enabled for UEFI mode boot configuration. This is a strict constraint. It's incredibly easy to overlook in a real-world deployment, and I can tell you for sure it is highly likely to appear as a troubleshooting question on your exam. Next, let's look at the major traps surrounding QoS policies. These are huge. First, if you attach a volume group to a VM, QoS is completely bypassed for that VG. QoS simply does not apply to volume groups at all. Second, for linked clones sharing vDisks, those shared disks are not throttled. A VDI boot storm can easily blow right past your intended limits. Third, when you clone a VM, the new clone does not automatically inherit the QoS throttle limits of the original. You have to go in and configure them separately. And finally, Storage QoS is entirely unsupported for metro availability. Okay, here's another exam-style scenario for you. You're tasked with setting up cross-cluster live migration, or CCLM, to seamlessly move a guest VM from your primary cluster to a secondary cluster. What is the one strict, non-negotiable configuration requirement at the storage layer? The source and destination storage container names must be absolutely 100% identical. If your VM lives in a container named self-service container on the source cluster, the destination cluster must have a container spelled and capitalized exactly as self-service container. If they don't match perfectly, cross-cluster live migration just will not work. And finally, Section 6, Key Facts to Memorize. This is your rapid-fire, high-yield cheat sheet for rote memorization right before you sit for the test. So, the crucial point here is the number 256. That is the absolute maximum number of SCSI disks you can attach to a single AHV virtual machine. By contrast, if you're forced to use the older PCI bus type for a legacy system, you are hard-capped at a maximum of just 7 PCI disks. Remember that huge gap. 256 for SCSI, but only 7 for PCI. Your next number to memorize is 100. When you are configuring throttled IOPS to restrict a virtual machine, the system literally will not allow you to set a limit lower than 100. It's a built-in safety net. It's there to prevent an application from completely crashing due to a misconfigured, overly aggressive QoS policy. Let's lock in our final 4 foundational facts. Number 1, SCSI is the default and best performing disk type. Number 2, if you cancel an ongoing live vDisk migration, AOS safely retains any unmigrated vDisks in the source container. It doesn't break them or delete them. Number 3, you need an AOS Pro license or higher to even touch Storage QoS. And number 4, if you're mounting containers as data stores in a mixed vSphere environment, NFS is explicitly recommended over iSCSI for performance and scalability. Take a moment to absorb all of these constraints and policies we've covered today. And before you jump into your lab to practice, ask yourself this. Based on the edge cases we just explored, how many VMs in your own cluster might be secretly bypassing their QoS limits right now, all because of a hidden volume group or a linked clone? It is definitely something worth checking. Thanks for hanging out with us for this explainer, and good luck on your NCP-MCI exam.